How do you find domain from real-world algebra problems? Have you ever wondered how to determine the domain of a function when faced with real-world algebra problems? Understanding the domain is key to making sure your function works correctly. Let's break it down step by step. The domain of a function is simply the set of all possible input values, usually represented by the letter. To find the domain, you need to consider the context of the problem. For instance, if you are dealing with time, only positive values make sense. Negative time is not realistic, so you would only include values greater than or equal to 0. Next, you should look for any restrictions that come from the function's formula. One common restriction is division by 0. If your function includes a fraction, the denominator cannot be 0. To find these values, set the denominator equal to 0 and solve for any x value that makes the denominator 0 must be excluded from the domain. Another restriction involves square roots. The expression inside a square root must be greater than or equal to 0. This means you need to set the expression under the root greater than or equal to 0 and solve for x. For example, if you have the square root of x minus 2, you would set minus to greater than or equal to 0 and solve for x. There are also other types of restrictions, such as logarithms. The input to a logarithm must always be positive. So, if you have a logarithmic function, make sure to set the input greater than 0 and solve for x. Once you identify these restrictions, it is time to solve the related equations or inequalities. For instance, if your function is f of x equals 1 divided by x minus 3, you would set x minus 3 not equal to 0. This tells you that x cannot be 3. Now combine these restrictions with any real-world limits. If represents the number of people, for example, must be a whole number greater than or equal to 0. Finally, express the domain clearly. You can use interval notation or inequalities. For example, if cannot be 3, you would write the domain as all real numbers greater than or equal to 0 except for 3. In interval notation, this would look like 0 to 3, union 3 to infinity. Let's consider a practical example. Imagine you have a function that models the cost, c of x, equals 50 divided by x minus 5, where is the number of items produced. You cannot produce 5 items because that would make the denominator 0, leading to an undefined cost. Also, producing a negative number of items does not make sense. Therefore, the domain is all real numbers greater than or equal to 0 except 4 equals 5. In interval notation, this is written as 0 to 5, union 5 to infinity. By following these steps, you can confidently find the domain from real-world algebra problems. This method connects mathematical concepts to practical situations, helping you avoid common mistakes like division by 0 or invalid roots.